see, the first thing I do is start streaming on YouTube. Okay. Hello, and welcome to the IPFS weekly call. This is the place where you get a chance to see exciting projects that are being built in the IPFS ecosystem. So we don't have any announcements for today, so we're going to get straight into the presentation by Bogdan Habik. Thank you, Bogdan, for agreeing to present today. Bogdan is a software engineer, and he's also co-founder of Tenderly. Tenderly does Ethereum smart contract monitoring. It does stack traces, analytics, debugger. It's definitely something that was needed in the space. I'm so happy that Tenderly exists. Tenderly uses IPFS, so it'll be really interesting for Bogdan to tell us exactly how they're using IPFS. So without further ado, Bogdan. Yay.
Okay, good. So hi everyone, she's Bogdan. Before building stuff for Web3, I worked at GoDaddy and got acquired by it. So there I was also building developer tools. So Web3 developer tools were kind of a natural fit for me and the people that love GoDaddy and started building stuff for Web3. So right now I'm working in Tenderly, which is an Ethereum smart contract monitoring platform. But it's interesting to see how we got to the idea. So before doing this, we actually built a decentralized public procurement platform. So public procurement is if the government wants to buy, for example, 100 shares, they have to make like a huge auction and people apply, etc. So there we used IPFS in Ethereum to make this totally decentralized. But the problem with that was that while developing all of that, there was a lot of friction on our side, especially with Ethereum. So while talking to government people, first we found out that we don't know how to talk to government people. So that was one of the problems that we couldn't solve. But the problem that we did manage to solve internally was actually building development tools. And we decided that we're having much more fun building that than actually solving the public procurement problems like corruption and stuff like that. So we started building Tenderly. So let's get started. So just to share my screen, give me a sec.
All right, share button's on the bottom, it's green.
Yeah.
Share icon, I should say.
So when I click this, do you still see the screen?
We can see it.
Good. Okay, so as you already mentioned, so Tenderly, just give me a sec. I actually don't see my mouse here. Just a second, sorry. Okay, here we go. So Tenderly, as I said, is the first Ethereum smart contracts monitoring platform that empowers you with real-time EVM level insights for every transaction on the network. Now, what does this actually mean? It means that we have Tenderly on one side, which we're running full archive nodes, and then we can actually listen to every transaction that's happening on the Ethereum network. Then we take every one of these transactions and we analyze them. And so far, we are analyzing everything, but we actually surface data only about failed transactions. So if a transaction fails, Tenderly catches the transaction itself, it analyzes it and uses the source code of the smart contract itself to give you a useful stack trace. And then we also have this as a CLI version. So if you're doing local development, there's usually stuff like invalid opcode or require that fails or something else. And you don't know where it actually failed. And coming from traditional languages, having a normal stack trace is a must. So we built a stack tracer more or less. So with that trace on the platform side of things, we can alert you, we can shoot a webhook, send you a Slack message, do something automatically and stuff like that. And so basically, I'm not going to go into too many details about this. On this specific link, you can actually see one of the co-founders speaking of how we built the tracer itself, which is totally open source. And he goes into great detail how you can max solidity bytecode from the bytecode itself to a specific line of code. So we did this with a couple of stuff. So we're using a custom EVM implementation. EVM is the Ethereum virtual machine. So we're running full archive nodes for both the mainnet and testnet. And it's interesting that the mainnet archive node is 2 terabytes of data, actually. So we have to store it somewhere. So we have our custom version of EVM, which is constantly analyzing all of the transactions instead of actually mining them. And then we have this whole huge custom data processing pipeline, which is a combination of Google Cloud Platform and Kubernetes on top, and Azure for running the nodes themselves. And we also use IPFS to store user contracts. So you can, later you will see, you can either import contracts from Etherscan, and then we're using the data they have. But if you upload it to us, we actually use IPFS for storing the data in an encrypted way. So you can join our Discord if you have any question about this, but rather than telling you all of this, let me show you actually how it works. So here's how a failed transaction on Ethereum looks right now. So here you cannot know actually where a transaction failed, and the contract itself is fairly simple. And we still cannot know where it actually failed, and we'll see what this contract actually does and how it uses IPFS. But here we cannot see any information that's useful. Even if I go to parity trace, for example, we can see that it just got reverted and there's nothing actually useful. And we will see how Tenderly can actually help with that. So to build this, and I'm going to actually do a quick build here to showcase this, how this works. We're going to build a decentralized password manager with Ethereum and IPFS. So what we're going to make is a smart contract, a really simple one, which is going to store an IPFS hash for us, which is a really common design pattern for Ethereum development. And then we're going to use RSA encryption to store everything in an encrypted way on IPFS. So to show you how this actually works, just give me a sec. So here we have a simple decentralized application, and here I can enter an account, let's say google.com. I can add the username and a super secure password 12313. And here I have stored my password, but this isn't useful if it's on my computer. So what I'm going to do is I'm going to say update master file. And again, because we know security is a must, I'm going to do 123 again here and do this once more. So I'm going to get a pop-up from MetaMask here. Just give it a sec. I'm going to confirm the transaction itself. And here we got the transaction hash. So if we go to Etherscan just for it to wait for it to finish, actually, give it a couple of seconds. This is column, so it should, there. So it got mine. Here we can see the actual IPFS hash storing this transaction. And if we go to the contract itself, we can see that the transaction was mine and we have stored it here. Now, how we actually build this and how this actually works. Oh, and actually another thing. So if I ever load this up, adapt using IPNS, for example, which we actually do, load it up, I can say load master file, enter the super secure password that we use. And it's actually going to query the blockchain for the IPFS hash, pull down the binary data, decrypt it, and show me the information that we entered. So if you can see 12313. So this is how we can use Ethereum and IPFS to store data, because in Ethereum it's too pricey to store data and it's really inefficient. And that's where IPFS shines to be a good data storage. So let's see what actually happened in the background for the demo that I showcased. So we have a JSON document that we used an encryption key, which was the master password that I entered. And we got some gibberish, which is binary data, encrypted binary data. Then we take the data, submit it to IPFS, and we get back the multi-hash that IPFS gives back. And then we take the multi-hash, send it to MetaMask to sign our transaction, and send the transaction to the Ethereum network. So the payload itself that it sent looks like this, which is fairly simple, where you have like a website, the username and password. And the encryption itself is really easy. And the thing that I love about IPFS is you can use like really simple stuff to make great abstractions to do complex stuff in a simple way. So what we do here is we prompt for a master password. We use Cryptico, a JS library, which is really easy to use to generate an RSA key pair. We stringify the passwords that we have. We encrypt everything, and we just send it to IPFS. And this is so easy, and we got the hash back. So now we can actually see the smart contract itself that we saw. So we have something called password manager, which has the password owner, which is the address of the person that deployed the smart contract. So that's when we have message sender. Then we have a really, really simple function called send hash, which just gets a string. And here we assert that the message sender is actually the password owner of the password manager. And this is actually where the first transaction failed, but we will see how Tenderly can actually map this to a specific contract. And then if the assert passes, we can store the IPFS hash that we send there. And also we have a simple view function, which is more or less like a utility function where we just return the IPFS hash that the password manager is holding. So again, a couple of lines of code, and we can use Ethereum and IPFS to store stuff, which is really cool. So submitting the transaction itself, we need a small setup. So usually on Ethereum, we have something called an ABI, which is an application binary interface, where we have an address of the contract, which is for this contract that I'm demoing is this one. And then we have an ABI, which is literally like an API that you can use to interact with your smart contract. So we build up the Web3 provider. We get the Ethereum account from MetaMask in this case. We pass in the contract details, so the ABI and the address, and we set state because we're using React. But here's where the magic happens. So after we added everything to IPFS and we got the multi-hash back, we can send the hash to the contract itself. And if everything works fine, we can just store the transaction hash from the Ethereum network and also the IPFS hash. And again, this is why I love IPFS, because like with 4 lines of code, this is stored almost forever. So how we do like loading an existing file, again, we prompt the user for the master password. We get the IPFS hash from the contract itself on the 3rd line with the get hash call. Then we use the files API, which is actually abstracted with the get IPFS method to get the file itself, convert it to a buffer. Again, we create a key pair with cryptico, and we just decrypt what IPFS gave us back. And if we JSON parse this, we actually got the passwords from the beginning of those slides. So again, a couple of lines of code, and you get public private key encryption, you get IPFS, decentralized storing, and you got the multi-hash also from a decentralized storage, which is Ethereum, which is good. So if we just wanted to, just for fun, if we wanted to actually see how we can make this maybe even better or cooler, whatever, we can use one contract for all users, which is basically using a map to map an address, an Ethereum address to an IPFS multi-hash, or IPNS hash also can work. We can use IPNS hosting, which on a workshop that I did, we actually did that. So we had Ethereum for storing the multi-hash, then we had IPFS for storing the encrypted payload, and we also had IPNS to host the whole thing as a dApp, so the whole thing was totally decentralized and indestructible. And then we can also use events as storage on the Ethereum network. So we can just replay events and in that way store information, but IPFS is much more usable. So to actually showcase how this works with Tenderly, so you remember that I submitted the transaction. We can see it was, let's see, 5 minutes ago, and it succeeded. But now if I go back here, choose a different account, which is this log one, we can see in the password contract that we have this require, which says message sender must be password owner, and password owner was the person that actually deployed the contract. So if I go back here and using a different account, which I picked here in MetaMask, I can try actually rewriting the account I just made. So this is the wrong password. So if I say update master password file, enter a different master password because I want to change and do malicious stuff, I'm going to get the MetaMask pop-up. Give me a sec. I need to refresh this. Sorry. Okay, so google.com. This and then update. There, we got the pop-up. We can confirm the transaction, which is going to happen on Etherscan now. And if we go here, give it a couple of seconds to fail, actually, this time. From 2, warning, error encountered during contract execution reverted. And again, if we go to the parity trace or whatever, if we have a complex contract, we cannot see it. And we're going to see how we can use Tenderly to actually debug this. So just for brevity's sake, I have verified this contract on Etherscan, so we can see the code you saw in Remix here. So I'm going to copy the address of the contract. I'm going to go to Tenderly and log in. I'm going to create a new project, which is going to be IPFS call, for example. Now, there are 2 ways to actually add a contract to us. So if you pick the CLI method, it is actually going to either upload to our Google Cloud or to IPFS. This is where we actually use IPFS. And we also have verified contracts. So I'm going to pick here Coven, which is going to use the Etherscan one. I'm going to say add contract. And here in the background, we're checking if the contract is valid. We're also going to pull the contract itself from Etherscan. We're going to compile the contract. And now if we fetch everything, we will actually see the transaction that failed a minute ago. But instead of just seeing this, which is unusable to actually debug something, if I go here, we're actually going to see the exact line of code where it broke. And this wasn't possible until Tenderly was built. So this is what we built. And this is more or less my demo and what I wanted to share here. So I'm open for questions.
Awesome. Thank you very much. So if you could stop sharing your screen, that would be
Sure. Give me a sec. Good. Very good.
awesome. Okay, awesome. Thank you. It was a great presentation. Do you have, if you have any questions, please put it in the chat. So all questions, please put it in chat. I have a question. Can you tell us, like, what is your wish list in terms of IPFS features? Like, what features would you like to see in the future?
So I remember when I was doing stuff with IPNS, it kind of, for people that are just getting into IPFS, it can be quite complex, especially when you want to map it to a CNAME, because you can map an IPNS cache to a CNAME and then like use regular domains to actually redirect to adapt that's hosted in an IPNS. So that was one of the things which isn't lacking. It was just hard to kind of figure it out for the first time when we used it. So I think that was the first thing. And I don't know, I really loved before you guys did like the WebSocket thing where stuff is published on the network when something's added instead of just like traversing the DAG. I wouldn't say it would have a pub sub feature, but now you have it. So then I'm good. So we're using it and we're really happy with it.
So I guess one of the takeaways is just having like clearer documentation for developers, individuals who want to get
stuff. Yeah, for more advanced stuff. So definitely the files API is so rich and you can do so much cool stuff with it. And then you have abstractions like get and add and stuff like that. But then if you like go to the files API after that, the complexity goes much higher. Like the learning curve is much steeper from that point on. So I remember I read a couple of articles on Medium that really helped me out, but maybe on an official doc, that would be one of the stuff that could help.
Well, what I can say is that we do have Protoschool, and Protoschool is a list of like activities so individuals are able to learn more about IPFS API and how it works. And if I'm not mistaken, their next lesson is on like dealing with files and handling with files. So if you can even take a look at that and like give us some feedback, we would love it. The person who created Protoschool is actually on this call, and that is Terry. So if you'd like to get in contact with her in the future, and like I said before, I can like send you the new lessons, and we would love your feedback.
I actually saw on the IPFS call, it was like a month back or something like that about Protoschool, correct?
Right, I believe that.
Yeah, we launched in January. So we have the one that I'm working on right now is specifically about MFS, the mutable file system version of dealing with files. And then at a later point, we would be adding something about the non-MFS version of dealing with files, but we're waiting for it to support blobs in the browser with that version before we build that content. So there is an open PR right now if you're interested in looking at the work that's in progress.
If you can send it to me, Portia can send you my email, and I would definitely love to look at it and give feedback. So
that'd be great. Yeah, thank you. Are there any other questions? We have compliments. We have Rad Demo Bogdan. Thanks for sharing. Heart your approach to developer workflow and debugging. Thanks for the walkthrough. I have another question. Have you worked with major IDEs, like for instance, Visual Studio or Sublime? Because this would be something that would be great to work with, like while I'm like a text editor.
So we actually have this thing that I showed you, like a dashboard. You can run it as a CLI itself. And we are going to work. So after we're finished with the learning for the platform itself, we're looking into actually integrating with stuff like Visual Studio Code, definitely because of the language server. stuff like that, and also to see like with the whole JetBrains suite of tools, because a lot of people use that as well, and maybe stuff like Atom and stuff like that. So what developers use. So, but right now it's a CLI because it was the easiest to prove the value that we're bringing in to work with what most people use. So that was kind of the reasoning behind it.
Of course, of course. Excellent. So if we don't have any other questions or comments, we'll end now. But once again, Bogdan, thank you very much for the demo. Thank you very much for the presentation. We really appreciate it. Yay. And I will see everyone next Monday for the next IPFS weekly call. Enjoy Earth Day, and I'll see you next week. Take care, everyone. Bye.
Nice meeting you guys. Bye.
Bye. Nice meeting you too.